So bell work today, first thing we do is we go through amplitude, period length, vertical shift, horizontal shift. Let's talk about each. So amplitude here. Sarah, what do you think your amplitude is going to be? It's 2. Great. Amplitude is 2. Period length here. Sean, what's my base period length going to be? Base period length would be 2 pi. Yeah, you're good. And then multiply by 3 over 2 pi. So like you said, it is 3. Good. Vertical shift. Alex, what's my vertical shift going to be? Down 1, because I got this -1 on the end. That's down 1. Horizontal shift here. Jake, what's my horizontal shift going to be?
I forgot how to do that.
Okay, so do we have a horizontal shift here? No. What would it look like if there was a horizontal shift?
There'd be something in front of the parentheses.
Not in front, in the parentheses, right? It's going to be added or subtracted inside that parentheses. If there was something there, that's what's going to shift me left and right. So there's not one there, it's none. The one thing we didn't worry about yet is the negatives. Okay, and again, we talked about this a second ago, but a reminder. If it's cosine and I've got a negative, how does that negative affect a cosine function? It doesn't. When we have a negative in front, using our even-odd identities that we've now talked about quite a bit, with cosine, it doesn't matter. If it were sine or tangent, then the negative would pop out in front. But if it's in this case, it just does not affect my graph. So that tells me that at least I have one negative, and if I have one negative, that means I need to flip this graph. Right? So let's put it on our paper. Y-axis and an x-axis. I'm going to be smart here, knowing that I'm shifting down a little bit. I can make it go down a little bit more than normal. 4 hash marks. 1, 2, 3, 4. I'm going to label this one 3. If that one's 3, Sam, what would this middle line be then? 3 halves. And what would the first line be? 3/4, because that's half of that. And then the third line would be 9/4, because he's counting 3/4, 6/4, 9/4. It's always 3 times that first one because the scale is 3/4 there. Questions there? Once I've done that, Lily, what should I do next? Not yet, because the amplitude is the stretch, right? And where do you stretch from? Yes. So we normally do amplitude. We stretch from the midline. So it'd be nice to have the midline first. Where's my midline going to be here, Lily? At -1. So we could do that. Mark -1. If I could write numbers, -1 is right there. And so we can make our midline. Again, just kind of think through that process. If I'm doing amplitude, it's from the midline. So if I do my midline first, that'll help me out. Okay, then I'm doing amplitude. Chris, where's my top line going to be? Where top line's at 1. What about your bottom line? -3, because he's going up 2 and down 2. -3. Make sure you're labeling those. Boom. Oh, I don't need that line. All right, cool. We are doing a cosine graph. So where do I start to make a cosine graph? Top, middle, or bottom? Bottom, because it's flipped. Yes, it's top, but I flipped it, so I'm at the bottom. So I'm down here. I didn't shift horizontally, so I don't have to mess with that. Bottom, then I'd go middle, and then I would go top, middle, bottom. Connect the dots. There's my graph. Questions on the setup on that one? Again, that's about as tough as a sine or a cosine graph will do. So if you can handle that, you'll be able to handle them all. As I said, today we're talking Desmos. And Desmos, we're exploring these different concepts. Okay? It's very much on you for you to understand what's going on. In the classroom here, the key is for you to talk with your neighbors. You're sitting by someone, you're thinking your way through it, talk with each other, and understand why something's happening. Okay? This first thing is definitely something we want to look at and be better at. Earlier, I just let him go without giving him any instruction, and it was kind of bad. Okay? So let's look at this one. So this is why we would use a trigonometric function. The temperature in a city varies from 4 degrees at midnight all the way up to 20 degree maximum at midday. Transform this cosine function to model that situation. So we're going to graph a cosine function that models this, that you have a temperature that goes from 4 degrees to 20 degrees at midday. What does midday mean?
In the middle of the day.
Which is what time? Noon. Okay? Notice that my scale down here is hours after midnight. Okay? How many times do you reach a high temperature during a 24-hour day? Once, not 47 times. One time. Okay? Use your brain. Work with your neighbor. Try to start piecing that together. We'll talk about it here in a couple minutes. All right, here we go. We are trying to get this to match. What are some characteristics that I need to have in my graph? What's something I know with my graph? What do I got to do? Alex? Midline of 12. How did you get a midline of 12? Yeah. My maximum's 20, my minimum's 4, and so the midline is going to be between 20 and 4, and so we have to get a midline at 12. So how do we get 12? Up 12, so we throw a plus 12 on the end. Cool, we're to that. Okay, that's our first thing. Then what? What else can I do here? Sean, what else do I need? Amplitude. What's my amplitude need to be? 8. Why 8? Good. Good. We have to go between 20 and 4. There's a span of 16 there, so we have to stretch 8 either direction. So we got that next. Okay, what else do I need? Jake?
Flip it.
I got to flip it. Okay, it's the coldest at midnight, and so we got to have that graph flip so we can throw that negative there. The only other thing I have left to do is period length. How long is the period length if I'm talking about a day? 24 hours. I need my period length to be 24. So we take 2 pi, we multiply by something, and it's going to get me 24. 2 pi times what would get me 24? 12 over pi. 12 over pi times 2 pi would get me 24. So what needs to go in front of this x? Pi over 12. There is my graph. We started off at midnight. At midnight, we're down here at 4. At noon, we're up here at 20. Then at midnight again, we're down here at 4. That's a good modeling question. How do we use a sine or a cosine graph to figure out what's going on? That was our main idea.